Welcome back. Today I'm not going to be working on KinoScript, but instead I'm going to be writing something in it, right? The idea is we're want to know. This is interesting because it's Turing complete, so that means that the language is Turing complete, which obviously you already know that, but this is a way of proving it, right? So I'm going to try to write it. We should have all the stuff that we need to do it. Right, so not super efficiently, like it's going to be kind of verbose, but I think we can write it. So let's try it out. Yeah, so in case you don't know, Rule 110, it's a cellular automata. Automata, however you want to say it. Yeah, like Game of Life, as you can see here. So I'll leave like a link to some sources in the description in case somebody is interested. This is going to be pretty short though, because it's not going to take too long to implement, because it's not that hard. Basically, you have these patterns, and when you have data, and then based on the patterns within the data, you figure out the state for the next cell. If that makes any sense. So, yeah, and then it looks like this, and you can generate cool patterns like this. Yeah, so to do that, we're going to need a data, right? And that's just going to be an array of integers. So this is going to be 64-bit integers, because we don't have a really good way of working with, like, less than that, you know, so booleans or 8-bit integers, something like that. Let's see, so to start, it's going to be 8, so 1, 2, 3, 4, 5, 6, 7, and then the last one I'm going to have 1, because that's what generates this cool pattern that you see here. So we'll do that, and actually I'm going to have a data size, and I'll set it to 8, and then we can use that here. And we also can use that in loops and things of that nature. Okay, so we have the data, and then we need a loop to loop over the data. So this will just be the main loop. Sure, we'll call it that. And it won't return anything, I don't believe. And at the end of it, well, actually, let's do this. New int data size. Alright, actually, maybe I'll just make it a pointer, right? Just an empty one, and then we can allocate data size times 8, because that is the size of a 64-bit integer. So it's going to waste space. And then I'm probably going to iterate on it as the language progresses to make it more concise and better, right? Okay, so we have that, and then we have to loop over it. So we don't have for loops. I'm going to use this. Yeah, this I. And while I is less than data size, then, and yeah, we need to make sure we do I equals I plus 1. And at the end of it, we're going to say data equals new. So basically just change where it points to. Before that, we can also probably deallocate data, because it is allocated, and we don't have a garbage collector at the moment. Yeah, so then in the loop, we have to check the values of things. Okay, so the way to do this, let's see. So we need to basically compare it. First of all, we'll get the indexes, right? So previous index, and if I can remember how to do this, because I have implemented this before, I use C. This is not C, so it's going to be a bit different. But let's see. So we have that. Basically, so we're getting the index in there. So we need I minus 1. But then we need plus data size. And it's going to be in parentheses. And then to wrap it around, we do mod data size as well. And we do a similar thing for the rest of them. So this will be current index. And this will be next index. But this is going to be plus 1. And this, I'm just going to make it plus 0, so it's sort of like consistent. Even though it doesn't do anything, obviously. Okay, and then now that we have the indexes, we can construct a string based on them. So, let's see, I think we can do... I think we're going to have to allocate like this. So we'll make a stir. So this will be the... this is going to be the current stir equals... we'll allocate 3. 4. We'll allocate 4 because we need the null termination. And I'll just set it like this. So previous index equals... data fed. Okay, so I did that wrong actually. Don't need a semicolon. It's going to be current 0. And then 1 and 2. This is current index, and this is next index. 2, 1, 0, 2, 1. Okay, so we have that. And so yeah, we're also going to need new size. This is going to be the size bit, and we're going to append to it basically. Okay, so we have this, and then we need to compare. Right, so this is a string basically, is what we have here. One string. We need to compare the string to different things. So I'm going to actually copy the string compare. If I can find that. String compare dot right here. I'm going to just copy that function so that we can use it. Where is the rule 110? I can't find it at all. What the heck? Am I blind? Build. Where is it? Oh, it's right here. I'm stupid. Okay, so we have that, and then we can compare it with things. So I guess the way I'm going to do that, I'll just use string literals. I think that should be fine. So if we don't have elif either, so I'm going to use else if, and then it's going to be a bunch of end stuff. Again, this just because we can do it now, right? So if we're going to string compare current, we need to actually do string compare current, and then 111, right? So this is a string literal, which corresponds to this. So we're basically taking the pattern. If we had binary literals, there's probably a way we could do it with that, but this is the way I'm going to do it for now. We don't have binary literals, so we cannot do that. Or binary, we don't have any way to use anything with binary. Yeah, so if that, and this returns 1 if it's true, so we get the end, so we need else if string compare, and then 110, then, and yeah, we need to, it's going to basically be a bunch of ends here. Whoops. Okay, so this one, so 110, and then 101, and 100, 011, 010, and 001, then 000. Alright, so I'm going to talk about an alternative way of doing this after, but not yet. So then we have 1, 2, 3, 4, 5, 6, 7, 8, right? So we need 8 ends as well. 1, 2, 3, 4, 5, 6, 7, 8. Okay, yeah, so it kind of does this. So that's why I need an elif instruction, which would basically just be, yeah, it would look like elif, but I don't have that at the moment. So this is what we've got, basically. So if that, then we're going to set new size equal to equal to what? So this will be 0. So this is basically what it corresponds to, right? Equals 0. Here, the new size will equal 1. And here, it'll equal 1. And here, it'll equal 0. And here, 1. And then the rest are 1s except for the last one. Whoops. No, go, and the last one is 0. Okay, so that, yeah, it looks a little silly like this, but it is what it is, right? I could also just use ifs, because it's never going to be the same, but I think it's fine. So we set it to that, and then we iterate through this, and we also have to iterate the new size, so the new size equals new size plus 1. And yeah, then we do that, so that should be pretty much generating the state, right? So maybe this will be gen next instead of gen next. So let's call it gen next, and let me see if it compiles. It did actually compile. Oh shoot, no, it's not the right thing. Rule 110. Go and run. It did compile. Okay, so that's cool. So I can't really see if it works yet, because I need a way to print, right? So we'll do print state, void n, and then I equals 0 while I is less than data size, and I forgot the then. Okay. So we need to basically see what the current index is. So if data I equals 0, then else n. So if it's 0, then we're going to print, let's see, that's going to be an empty one. So I'll just print a dash for now. Otherwise, we'll print a star. I think that looks the best. So let me try print state. Let's see if any of this works. And it goes forever. Because I know exactly why, because I forgot to iterate it. I equals I plus 1. Okay, run that. And we printed out one of the states. So that we can see this is the 1. This is what we initialized it with. It was 0, 0, 0, and then 1. So I will... I want to print a new line here. Now I'm going to add another print state right here. And it should, and something is not right because, yeah, that's not right. It's supposed to get set to something else. So I messed something up somewhere along the way. So current 0. Okay. I equals I plus 1, so we do that. That's fine. Data equals new, right? We're setting the value of new. Something is wrong. We have string compare, and that should work, right? Let's see. Yeah, that should be fine. Let me write wrong, right? And see how many times it runs that. It runs that a lot of times. Does it ever run? Is it ever right, basically? Right? Let's see. No, so it is not. So it is an issue with that. It doesn't like the string. We have a string here. I have to set the null termination. That's not it. Oh shoot, you know what it is? I forgot this. You have to do this to make it a character. Otherwise, it is just the ASCII value, right? So in this case, like if it was 0, it would be the ASCII value of 0 and 1 and such, which I don't remember exactly what that is. ASCII table, I can look at that. 0 and 1 are, in fact, null. Yeah, okay. That's what the issue was. Yeah. So now if I run it, okay, this is what it's supposed to do. So it looks like that. So I could do a few more iterations, right? And let's see. Okay, I messed something up. I think it's with the copy paste. Yeah, okay, I pasted a weird character. We can see it's starting to build that something. So I think what we want to do is probably make some sort of iteration is less than data size then n. We don't have iter, so I'll declare that up here. I like to declare the global variables at the top. Because I think there's going to be an issue if we don't. Because the way I handle it. So I can check. Yeah, it say false. And I don't know why it would do that. So I need to look in the code. But I forgot to iterate it. Let's iterate plus 1. And there we go. So you can see it's starting to build something out, which might look familiar to you. If you're familiar with Will Warner Know It, it's starting to look like this, right? So I've set it up so the way I can change it this one variable, and that's gonna allow us to increase the size of the whole thing, right? Almost. Okay, so if you look here, I do this. So I'm just gonna zero initialize the whole field, and then I'm gonna set data size minus 1 equal to 1. So that's gonna initialize them all with zeros, and the last one is gonna be set to 1. And then there we go. So we're starting to build something out that looks an awful lot like this, right? Maybe not exactly the same, but it's pretty similar. So let's maybe make it 128. I think that is a good looking one. Might have to zoom out a little. But yeah, you can see that's pretty cool. That's pretty cool. Might get a little messed up in the recording, but it's pretty cool. So let's do a 32. I think that is more reasonable. Okay, so that works. Something else to make it maybe a bit better looking. Put a space here. And then also have some borders, you know? I think that would make it look a bit nicer. Yeah. So there we go. You can sort of see the boundaries, but you can see it's building out some cool shapes. And it's not limited just to this, right? So if you want, let's see, if you want to do something like this, you can sort of randomly initialize it. I should probably make even a function for that, but that is, it's going to make a few patterns like that, as you can see there. It almost doesn't feel 32 wide, but I guess it is. Let's put a couple more ones in there. And yeah, you can see it makes some cool patterns. So maybe we could even, let's see. Let's start out with iter here. Long iter is less than data size. Then I just want to set it all with ones, right? So it's going to be data iter equals 1. So what if they're all 1? Like, what's that going to look like, you know? So I think I don't even have to change that. And then I'm going to set iter back to 0. And actually, I cannot forget to iterate iter. It equals iter plus 1. And we don't have, like, plus or anything like that. So, and yeah, okay, it just makes it all 0. So maybe leave 1 at 0. So start iter at 1, you know? The first one will be 0. Yeah, then it creates some patterns here. So you can see it goes like this. And then it kind of defaults to how it was, which is quite interesting, actually. Yeah, you can make some cool stuff with this, though. So, that's pretty cool. But yeah, most of these just turn into 0. Because of how the patterns work. If you look in, if it's all 1s, then it becomes 0. If it's all 0, it also becomes 0. So when you have 1 at the corner, it makes this cool pattern because it looks like this. So it creates 1, and then, you know, creates a triangle out of it. But yeah, that's pretty cool. I'm not gonna start with that though. We'll send this back to 0. Yeah, so we can create quite a few iterations. And actually, let me change that. Because I like the way that this looks. You know, this is very cool. And yeah, you can make it any size. I just want to get it ready. And I'm gonna put it into the examples because I think that's pretty cool. Pretty cool to have. All right. So something else. I could use structs for this, where each one has a string within it. And then also the value. So like the string and the value of 0, string and the value of 1. You know, in this case. The reason I didn't do that is because I don't have a good way of initializing them at the moment. Because you can create a struct, right? So I could make a struct pattern, right? We'll call it that. And it could have a value int, right? And then a string. So this is like the pattern int, right? I'll just call it that. Int string. Right, and you can do that. But then to initialize it, you have to initialize the struct first. So you have to do pattern equals value equals 1, pattern equals 001, right, like that. So you can do that, and then if you want like an array of them, you could do that as well. I'm gonna spell pattern, right? It could be a pattern array, so patterns equals 0, and let's actually make it an array of 8, and then you can set each one, but you can't just set it, right? Because I don't have this parsed as an expression currently. Which I could do that. There's some ways I can do that, but you can't just go like patterns 0 equals this. You have to set it, and then you can set patterns 0 equals pat, right? And then that compiles everything. So you can see, like, I'll have to do that each time, which that might be better. So maybe I'll try that. Yeah, just to correspond to each one. So value equals 1. So 0, we'll start with 0 for 1, 1, 1. And then it goes 1. 1, 1, 0, 1, 1, 0, right? And 1 again. 101, okay. 0 for 100. And then 1 for 011. And let's do a few more. Alright, so it's 1 again for 010. And then 001. And there's 1 more. And it is 0 for 000. And I need to actually change the names. Maybe this will work. Alright, so it does still compile, but I don't know if it's gonna compile. Well, I'll try it. Yeah, it's like shadowing kind of, but it might not work. So then if I get rid of this, it won't, well, I kind of have to just get rid of it. It's not too hard to put back, so then I'll iterate over it, so, and I need to get rid of all these ends too, because that's gonna look a lot nicer, obviously. So while, current is less than 8, right, because that's how many we have, then n. And we'll do, current equals 0, and then patterns current. So if string compare current and per. Oh shoot, so I can't call it current. Current. Let's call it current. That's fine. The cur pat. I think I can use underscores. That should work fine. Cur pat. If that, then it will set the current one equal to that. So it is data, not data, but new size equals patterns per pat dot value, and this one is dot pattern, I think is what it's called. Expect token dot ag. Oh shoot, does it not like that? Oh shoot, we can't index an array like that? Uh-oh. I didn't even think about that. Okay, so I don't have support for that even, so that's not even going to work. But I could use the get from it. Right, I had the get function, so I could get get that 0. Is this gonna work? It's not max. Does not max that, so it doesn't like this either. Get patterns. Yeah, okay, it doesn't. It does not like. Well, what if I wrap this in that? Okay, it did something, but then it error expected pointer. Okay, yes, then something broke. It was actually in the runtime. It failed. Okay, so yeah, that doesn't quite work. Yeah, so this is like, you can see how this would construct, right? So what I need to do is make a better way to initialize this, and I need a way to get it from the array. For now, let's get rid of it though, and I'll put it back how it was. Oh, but yeah, so you can get an idea of how that would probably work. So I get rid of that, and then, so if, I'm just gonna write a series of if statements instead of the else, and then there doesn't have to be all the ends. So if string compare, so I kind of have to write it again, but that's okay. 111 and current, then end, and yeah, so let's copy this. 000 001 010 010 011 011 100 101 and 110. Okay, then we'll set new size equals, in that case it's 0, and then 1, and then it's 1 again actually, then 0, then 1 1 0 1 1 and 0. Okay, and let's see, that should work. Yes, that works again. Yeah, so I'll need to work on that. There is a few things. Maybe I'll even create an issue for that so I don't forget. So I'll just do script. Actually, I saw an issue that I could close in there that I forgot about. Script. Script. What is it? Array of strings. Not get a field from struct stored within an array. Okay, yeah. So that, and then there was something back here. What is this? Can be changed in variable initialization? I don't remember what I mean by that. Struct names can be changed in variable. Okay, I don't get that, but oh yeah, that was like the fields. I think I fixed that. But this one I know that I did fix. This was actually the last stream. I fixed that, so that's all good. Close that, and I think we can return arrays now. Well, not like that, but you can return the pointers to them. Anyway, that's not very important right now. Okay. So I've got that. Rule 110, right. I'm going to take a look at the generate assembly here in a second as well, because that might be interesting. Okay, so that all works, and it like wraps around, you know? Yeah, you can create it any size you want. Right, so 128. That's kind of big, but you know, get the idea. I think 32 is a good size to look at it. Maybe even could go up to 64. Yeah, but then it kind of goes out of. I'll do 32. So I think that is good. So I'm gonna copy and paste rule 110 dot kano to, I think it's called test. I'm also gonna write something to actually test it. But for now, let's take a look at the assembly. So it's kind of long. It's yeah, 648. That's quite a bit. Just an empty label here. Okay. All right, yeah. So you can see there's quite a bit of stuff going on here. So we push 32. That's the initial size, and then here is where we are indexing stuff. Oh yeah, so we're actually pushing 8, and then stack size. Yeah, because we're grabbing this variable that we have here. That's pretty cool. Yeah, it's kind of verbose. You know, like it could be the assembly could be a lot shorter than this. Because I don't have any optimizations going on at all. It just generates exactly what it sees. I would like some optimizations in the future. You know, okay. The assembly's probably not very interesting, but you know what might be interesting? I could time it. Time. Let me run that, right? So the, that, it'll run SH. Run SH, that actually includes compiling as well. So let me see. So that is, it is 30.031 seconds to do that. If I, tire. So that's with the compiling. But then if I do rule 110 dot, 10, then I can time it. 0.02, okay. Yes, the compiling and assembling, like it compiles and assembles. It doesn't even take up that much time, which is kind of surprising, actually. Also, there's not like buffered I/O or anything like that. Well, there might be, since C on the, maybe not. I don't know. I'm not sure, but I could compare this to the C one that I wrote. So if I actually get that, yeah, no, it's right here. So let me build that and run it, right? And it's actually a bit larger, so let me change that. Let's make the size 32 as well. It's gonna be a lot faster, obviously, because it's C, but So let's run that, and that is not right. What the heck? Alright, something is not right here. I didn't think I'd be having. Oh yeah, iterations. Let's just set it to size. What's it build? Yeah, there we go. So that was better. And let me add the borders as well, because I think that looks better. So I guess I'm making a commit to this as well. Yeah, we also use put C here. That is it. Alright, so print grid twin. What does that mean? What the heck? I don't remember this very much. Here we're writing that. So let's do this. I think up here. Yeah, I don't remember. I guess I was doing some kind of complicated stuff here. Also, I only had 2 spaces. What the heck is this? I don't remember this. I mean, I remember writing it, but I don't remember this part specifically. That didn't even give it borders. What the heck? So what does this do? I guess this is where the borders would go. Why is it 2 spacing? I don't remember having 2 spacing ever. And I didn't write this that long ago. Okay, there we go. So I gave it borders. So the output should look... I guess I could use tmux for this even. Let me use tmux. So they are more side by side. So it can be directly side by side, you know? CD 110, build it, and run it. Okay, there we go. So they actually, they output more or less the same thing. How do I get up here? Whoops, this is actually... yeah, pretty consistent time. And let's, time this. And yeah, you can see it's a lot faster. Which is fair. Like, obviously it's going to be faster. All things considered, right? Because this is running C under it. There's probably some things I could do to make it quite a bit faster. Like, if I optimize the code some. Of course, wait, let me even turn optimizations off, right? On the C one. Alright, Kano build SH. Let's do O0, so all the way up. It's probably not going to make too much of a difference, but, you know. Okay, it didn't make any difference. What did? I turned them all on. I'm just messing around, kind of. It is frozen now. What the heck? Why is it frozen? What happened? What? Okay, I don't know what happened there, but let me do that. It does still work, which expected, but yeah, it doesn't make much of a difference. So let me close that out. So you can see it's a lot faster. Let me try turning on optimizations here, which might be interesting. I don't know if it's even going to work if I do that, but obviously it takes a lot longer to compile. What is this? Call to reality here. So there's some issues in the Lexer. Hunter is used after Realic, huh? Okay, so I have some issues here. I'll look into that. I didn't know that I had it. Is that... I didn't see that before, but let me see if it still works. It does actually still run. And it is faster, like that's with the compiling as well, so... 110.10. Alright, time it. And okay, so that is that's double the speed, so that's not too bad. So if I implemented some optimizations in the compilation stage, it could be even better. All right, that's actually that's pretty cool. So that's not too bad then. So it's 10 times slower than C. I think that's reasonable. And I'm kind of tempted to write it in Python as well. Just compare that. Here. Let me just see. So let's see. How does Python work? Alright, we can have, I don't want to do this. I don't really know Python. I don't know if I'm going to write this, actually. So, while, for I in range of data size, let's make a data size equals 32, and then data array. You define arrays like, or lists, right? How do you define those? Equals, list. Right, so that's the list. It's 0 initialized. Data size minus 1 equals 1. Let's print out data. So what is that look like? Again, I don't really know how to Python, so Python rule .py. find data size. How does this work? Yeah, okay, maybe it's not. I'm gonna do Python. Data is not defined. Alright, yeah. Python define list of size. How does it work? Let's see, this will just give me a quick answer. Alright, 9 times 10, actually, I can do that. Equals let's do 0 times data size, right? That's the one again. Yeah, like that. There we go. And that works. Alright, that is exactly what I want. So now I can iterate over it in the same way for I in range of data size. Okay, so if I do it like that, and then I can grab the indexes again. So I'm just going to basically write the same thing. So parent in equals, equals I. So I have the index minus 1 plus data size mod data size. Okay. So you're going to write it the same way. This is just for fun. Plus 0 plus 1. Okay, so we have all the indexes, and let's set the names. Current index and next index. Alright. And then we can construct a string out of that. If we equals, let's see, I don't know if we can use the name string, but anyway, data print index plus 0. So I should be able to, well, hang on, what if I even just do stir that, right? Stir of that plus stir of data index. I'm not sure if this is the best way to do it in Python. But it is something, right? Alright, so that should construct the string. And let's actually print the string now. Okay. Yeah, so it did actually construct the proper strings. And then so then actually I'm gonna create a new as well. Alright, I'm gonna make a function for this. So this will be gen next. Yeah, so I'll just call it the same thing. Def gen next, okay. Indent that, and we'll make a new one. Equals 0 times data size, so 0 initializing. And then we'll have, we can just append to it even. Yeah, so we can even just initialize it empty. And then just append the string. So we'll need to compare it. So we can actually do that like a proper way. So how do you make like classes as structs, right? So structs. Like how does that work? Class, yeah, so data class, that's what you have to do. Let's see. From data class, import, what was it? Just data class, so data class is, and then I'll do at data class. This will be class pattern, right? And then you can just initialize it like that. Yeah, okay. So this will be the stir is a string. Is a stir, and then the value is can you do it like that? Yeah. Okay, so that seemed to have compiled. Then we can create an array of these. What's the best way to actually initialize those? Okay, you can do it like this. So point. Okay, yeah. So create an array of patterns. So patterns equals pattern. So we'll have string 111, which corresponds to 0, and then pattern. What were they? 110, which is 1. Pattern. Alright, 101, which is 1. Pattern 100, which is a 1. No, which is no. Yeah. 100, which is oh. Yeah. Alright. Okay, brain fart. Pattern 011 is 1. 010 is 001 is 1, and the last one is pattern 000 is 0. Okay, there we go. Got it. And let me make sure that works. Okay, so that does work. We didn't get any complaints. So we can iterate over it. For J in rain, and let's do in patterns. Let's just do for pattern patterns. If that equals string, then we want to set dot append. Do if pat dot string dot append pat dot value. Yeah, do that, and then set data equals new. But do something like that. So let me cut away that, and let's actually call it. So gen next. Okay, so it doesn't like that. In line 29. Alright, it doesn't like cannot access global where it is not associated with a value. Oh, okay, because we need to like do global data, something like that. This index out of range. Okay. Why is that? Current index. That is not good. It shouldn't be out of range. Just on the current one though. That's interesting. What the heck? Alright, let's see. And let me look at one of the Pano, and that's the same way I did it, right? Plus 0 plus data side, yeah. Okay. What else could I do instead of that? Print it out. 0 and then 1. Why is that out of range? Because I need to do times data size, right? Oh shoot, no, this is the wrong one. Okay, I went to the wrong one. That's the wrong one again. Why can't I just open the correct one? Okay, so I do times data size, so why doesn't that work? Why is that out of range? I don't quite get that. What? In. Actually, let me put it on a different one so it actually come down. Okay, 0, 0, 1. So 1 is out of range. Why? Data size minus 1 equals 1. Times data size. So that should be 32, right? And let's see. Python create list of size. Did I do it wrong? No, hang on. So let's print out the data again. Data, right? Look at that. Alright, it's only 1, so why is that? We're not using new, right? Data. Alright, what if we pass it as a parameter instead? It's still wrong. Well, hang on. The first time it's not. Oh shoot, but we set data equal to new. Yeah. Because we want to use outside the loop. Okay, there we go. So we don't actually have to do that again. We can use it as a global again. Because that was working. The problem was we were setting it equal to this one, which was not the correct size. But now we can do that, and yeah, so we do that properly. So now we don't really want to print it every time. But it does work. Okay, and then we want a way to print it. We can't just print it out because that doesn't look very good, right? Print pattern, and we'll just iterate over it. So for I in range of data size, if data, well, actually, I think I can just do for I in data size equals 0, else. Alright, so I'll just print in this case. So if it's not 0, I'll print a star. Otherwise, I will print a space. And at the end, I will print, I think just print nothing, and that will print a new line, right? I forgot to print pattern. Alright, so you can't iterate over what? Or adding data. I equals that. There we go. And you know what? It prints a new line every time, doesn't it? Python print without new line. How do you do that? This one's taking longer than the one in my own language. I guess I'm more familiar with it. So n equals none. Okay. It's none. Okay. And there we go. So print out one iteration. That was 2. Why was that? Yeah, that doesn't work. Okay, I don't know, but let me do a loop. So for I in range of 10, do all that. And there we go. So it is constructing something. I don't know why it starts out with 2, though. Oh, because we printed after. I want to print it before. There we go. Okay, so let's do for I in range of data size. And okay, looks pretty good. So equals 32. Let's take a look at how that looks. Data size. Okay, yeah. Let's compare the time. So the time is, so ours was 0.01 at the fastest. Time is 0.044. Alright, so that's not exactly fair, right? Because that's basically the equivalent of run acceleration for us. So let me try that. It's still way faster, okay. Yeah, so faster than Python. Let's freaking go. Let me add the borders as well. Print that and equals that. And then here I want to print that. And okay, there we go. So now it looks the same. Yeah, that is pretty slow though. Yeah, anyway, that did work. So I am very happy with that. So let me add it, and that's gonna be the end of the video. Not too long, but it was pretty fun. So implement will 110 example. Push that. Alright, I'm actually pretty happy that it was faster than Python. Yeah, like way faster. So that's not too bad. So this should have worked out. There we go. Yeah, so thank you guys for watching, and I'll see you guys next time. Bye.